Hey, this is the 5th video in a tutorial series where we make this animation with a Blender+Python script. Hi, I'm Victor Stepanov. I'm super excited that you're here. Let's jump into part number 5. We're going to be creating a stack of curves in this video. We'll make sure that each one of these curves looks unique and generate a different form each time we run the script. We'll also work on offsetting the animation and finally getting the camera into place. Let's create a mental model for the changes we want to make to our script. In the previous video, we animated the shape key. Let's think about it as a single step for now. To create 100 curves, we'll need to repeat the curve creation process 100 times in a loop. Next, to make a stack, we'll need to set up a new location on the z-axis and apply that to each individual curve. After doing that, we need to update how the deform vector is calculated to make each curve look unique. Next, we'll offset the start frame for each curve animation. And finally, we'll place the camera into its final location. Make sure to keep this in mind as we make changes to the script. As always, you can find the code that we're going to be starting off with under Start Code in the description for this video. I'll also post a link to the code that we're going to get at the end, right underneath that. Before we start stacking the curves with Python, let's do this with our hands. I'm going to go over to this 3D viewport and then press Control Space to maximize the viewport. Now I'm going to select the curve, press Shift D to duplicate it, and then G to grab it and start moving it along the Z-axis. I'm going to hit Z to lock the movement on the Z-axis, and I'm just going to bring it up slightly above the first curve. Now I'm going to hit Shift R to repeat the same action. I'm just going to be continuing to hit that. And just like when I get tired about here, I'm just going to stop. And I'm going to press space, and you could see that there's an animation going that we created in the previous lecture. Now I'm going to hit space again. This is what we're going to be doing with Python in this video. I'm going to press Control Space again to exit out of the maximize mode, and we're back in the scripting workspace. Now let's do this with Python. I'm going to create a variable to hold the number of curves we want to stack, and I'm going to use a loop to stack the curves. Now let's run it and see what happens. It's going to remove all of the curves that we created by hand and add 100 curves. As you can see, if you look at the outliner, we have 100 bevel objects and 100 circles that are our curves right here. So they're just all in one place, 100 of them, right? We don't really want that. We want to stack them. So we'll need to change the Z coordinate for every single one of these curves. Let's do that. I'm going to pass this new Z location into the purlin curve and then use it inside there when we're creating our curve object. Now let's run this. All right, I'm going to hit Control Space to maximize, and as you can see, you have 100 curves stacked. I'm going to press space, and as you can see, all of them are animating. But they look pretty boring because they're using the same noise. So let's fix that. The reason why we're getting the same noise every single time is because if you select one of the top objects, or even any of them, go into edit mode and select one of the verts, press N to get the transform. As you can see, even though this is at the very top of this shape, the coordinate for this vert on the Z-axis is 0. This is because we haven't applied the location. If we do that, we're going to see some different noise all over this shape. So let's do that. I'm going to go back, and to actually apply the location by hand, you usually go and hit Control A and then apply location. We're going to do it differently in Python. We have a special function for that, and it's called apply location. This apply location is defined above in the helper functions. You can take a look. I'm going to probably make a separate video on that if anybody's interested. So I'm going to hit N to hide this transform, and then I'm going to run it. As you can see, this is not what we expected. This looks very messed up. And if we hit space, it actually goes back into shape. So it looks like something's wrong with our deform vectors that we created in part number 2. So let's figure out what's happening. Close. So now if we select one of the top objects, hit tab to go into edit mode, click on one of the vertices here, and then hit N. Now you can see the transform and the Z coordinate is actually not equal to 0. So that's good, but that really messed up our shape. Let's hit N to close that, hit tab again to get out of edit mode. I'm going to select just one of these curves so it could be easier to understand what's going on. I'm going to go to the bottom where we have our loop, and then instead of going the full range, I'm just going to go from, let's just say 10 to 11. This means that we're going to add only one curve, and let's see how that looks. Run it, and then let's hit Control Space and go into our viewport. So let's take a look. As you can see, it's coming back into shape if I do the animation, but when it's deformed, it isn't on the same plane. So if we look from the side, it's only on the same plane when it's not deformed. If you remember on video number 2, we were calculating the deform vectors, and they were all on the same plane. So we would have coordinates that would go either direction, and then we would calculate the deform vectors that would push the coordinates in or out depending on the noise value. The thing that's happening here is that we have the vectors that define the coordinates for each vert above this plane. So let's see where they are. I'm going to play the animation. And let's draw the vectors. So it's somewhere here, and for example, somewhere here. Play the animation. And as you can see, when we're calculating the deform vector, instead of it going from side to side, it's actually going this way and that way, right? So this way or that way. To fix that, we would need to ignore the Z coordinate when we're calculating this deform vector. I'll show you in just a second. Let's go to the top into the gen Berlin curve function and fix it. So instead of using the vert coordinate that has the Z axis set to wherever the location of the circle we're adding, right? We're just going to remove the Z value and set it to 0 and just call it projected coordinate and just replace the current vector with this one that we just created here. And let's run this. As you can see now, I play the animation and it's now fine, all on the same plane and nothing sticking out. Hit space again, and let's go to the very bottom of where our loop is, and let's do this for not just one but all of them. Run this again, and now you can see I have something interesting. Now let's offset the animation of each of these curves. If I just play the animation for all the curves, as you can see, they're animating at the same time. I don't want that. I want to make add a pause into that. So if you look at the bottom, we have the animation starting at the beginning and at the end for every single curve. So if you select any of them, they're all starting and stopping at the same time. We don't want to do that. So let's add a delay for all of them. Let's go over what I just did. I added a new variable called startFrame and passed it into our animateCurve function. Then I went into the animateCurve function, added the parameter that we just created, and added the loop length and set it to 60 instead of using the full length of our animation. Then at the very bottom, I'm just adding 1 to the startFrame and returning it. So every single time on every single iteration, we're gonna use the startFrame from the previous calculation. So we're gonna start with 1, then it's gonna go into this function. It's gonna do all these insertions, add 1, so it's gonna be 2, return it, and then when it's gonna loop again, it's gonna be passing in 2, right? And now we're gonna do this 100 times, the number of curves that we're modifying here. Let's run this. And now if you select random curves, as you can see, the start and the middle and finish for every single one of these are offset, and the length of them is equal to 60. So let's play the animation and see what it looks like. As you can see, it's going with an offset. You might have noticed that every single time we run the script, we get the same shape. This is because we're using the same locations every single time. We can change that by calculating a random location and using that to offset the coordinates of the vertices we calculate the noise. Let's do that now. So right here, we're creating a random location with an X coordinate, a Y coordinate, and a Z coordinate. And we're using the random uniform function to get a value from 0 to 100 for every single one of these coordinates. Let's pass this new location into the calculation of the noise. So instead of using the vert coordinate, we're adding the random location we just created and using that new location to get the noise value. So every single time we run this, we're going to get a different result. So let's take a closer look and run the script a couple of times. And run it once more. As you can see, every single time now we get a new shape. If you look at the outliner, you might have noticed that we're creating a lot of bevel objects for every single one of these curves that we create. So we're calling the create bevel object every single time we go through an iteration of a loop. We don't really need that. We only need one bevel object because they're the same every single time. Let's fix that. So let's see what I did. I moved the creation of the bevel object and added it right here, right before we go into the loop. So we only do this once when we run the script. And I'm setting the value and saving it in a dictionary and calling the object or the key as the bevel object. Then passing our dictionary context right here into our function. Here's the context right here, and then accessing what we just saved right here and setting the bevel object. So I'm going to run it and it's going to do the same thing. As you can see, we only have one bevel object now because we're creating it a single time. I also want to change the radius and be able to set that outside of our loop. So I'm gonna just do this. And I'm gonna set the radius to 0.1. You can set it to whatever you like. I'm gonna run it. And for our final touch, let's set up the camera to point at our shape. As you can see, the camera is now pointing at our object. If I had 0 on the numpad, you can see the shape now is going to be in view, and if I play the animation, you can start seeing the final scene. If you're following along with Blender 2.8, you'll need to find the setup camera right here on line 137 and replace this code right here with the following you see on the screen. Alright, make sure to save your progress. If you're feeling a bit overwhelmed, that's a good sign. That means that you're learning. So if you have any questions, make sure to leave them in the comments. In the next video, we'll be adding a material using Python script. Make sure to subscribe to not miss it.